Good morning. Today I will tell you about the history of the polymers. Just like a 4 billion years ago, our earth was just like a chemical laboratory or chemistry lab where we have the different kind of elements like carbon, oxygen, then hydrogen we have, then nitrogen as well. Then they reacted together to form simple molecule like water, ammonia, methane and hydrogen. Then thereafter they reacted together, then forming a big molecule that is called amino acids. Then the combination of these amino acids brought into a simple or a little kind of big molecule again, that is called peptides. Then reunion of these peptides converted into a very giant or very huge molecule that is called a protein. So, we believe that this is the building block of the life what we can see on the earth. So, this is in this way the life is started, evolution through ages, one part become a human being. So, nature itself created some kind of the polymer during its starting. We can say the other form just like the polymers appeared in the nature as well. For example, what we can have here is the wood and the cotton, and we can see the cellulose, fibrils, and we can have some starch in the food items. So, we have the naturally occurring polymers and what we found out in the living system and non-living system. For example, we have in the living system in the human beings, we have our body is made up of a lot of proteins, and that's we can see the natural polymers. And what we found out in the non-living system or what we found out in the wood and what we found out in the food is another type of the naturally occurring polymers. So, during the civilization, human beings they were trying to find out to meet their requirements by using these type of the material. So, what we can have here is we have the in the early ages the humans they use the skin of the animals as a clothings or dressings, and some of the leaves of the trees, that's for wrapping the food or any other covering properties or covering uses. So, during this especially in the 15th to 19th century, the scientists they were trying to find out these kind of the material or try to synthesize this kind of the material. For example, we have the famous discoverer Christopher Columbus. When he was traveling through the world, he saw the natives of the South Americans, they were playing with a solid material that has a bouncing property. They told that this is a extruded of a weeping wood that is coming out by barking the cut of the tree. So, we can have some bouncing property of this material that makes the use of the ball for the game actually. Then later another scientist Joseph Priestley, he found that the mark of the pencil on a paper can be easily rubbed off with this material, that is why he named this as a rubber. Then we have another scientists actually, therefore different findings, different chemical experiments they made. Some of the accidents we can say that was quite useful. A Swiss scientist, that is Christian Schoenbein, he was doing some chemical reactions in his laboratory actually. He was have some nitrating mixture. For example, we have a mixture of the sulfuric acid and nitric acid. He broken the beaker and it was just spread over the table. Then he was trying to wipe out these things, and he used actually his wife's apron, and he got panic and he just went out and he tried to dry the apron by placing near to a fire actually. But unfortunately those got fire actually. Then he may be afraid about that, she will be scolding him. But later he realized that this is something like a apron is made up of the cellulose, it got nitrated actually, it forms a nitrocellulose, it can easily got fire. Later we discovered that that is a nitrocellulose or derivative of the cellulose that can be used for a gun cotton actually. Then long time before we have used the for example, we have the ivory bowls that is made up of the tusk teeth and any of the animal teeth etc. We want to make something like a very hard material. So, scientists were looking to find out an alternative instead of using these type of the material. Then another great scientist, what we can say, John Wesley Hyatt, he found out or he discovered a material that is called cellulose. We say this is the first industrial plastic they made or he made to replace these type of the ivory things actually. So, as we are familiar with the many of the celluloid films etc. that is used for the film photography. So, an important revolution, what we can say, an important change that has found out or that we can observe in the history, that is the development of the a resin that is called phenol formaldehyde resin that is made by a great scientist, that is Leo Baekeland, in 1909. Actually, this was the forerunner of the mini plastics. He just simply found out some reaction between the phenol and formaldehyde. He found out a sticky material. Actually, many scientists, they tried before these type of the reactions, but one of the problem was it was going to stick on many of the glassware or apparatus or what are the reactors we are going to use for the particular chemical reaction. Then only after Leo Baekeland found out that this is a phenol formaldehyde resin, we can make into a hard material by fusing or by application of the thermal energy or heat. So later we named this plastic, that is the phenol formaldehyde, as a bakelite. Then after that we can see that there is a lot of the material that is used, phenol formaldehyde is used for making. For example, long time before, we have the telephone that is made up of these type of the thermosetting polymer, that is the phenol formaldehyde resin, and some of the plastic switchboard is also made of this bakelite actually. Then it was just like a breaking actually. Then later soon in 1912, another scientist, that is Jacobs Brandenburger, he found out or he discovered another material that is a transparent plastic, that is cellophane, used for many applications. So as you can see from the history, so the polymer revolution or the finding or discovery of the new materials, that has started even after the discovery of the radio, that is discovered by the Marconi in 1895, and even also the Wright brothers, they found or they discovered the aeroplane. So immediately after, there was a great growth of these things in the daily life, or what the material, how it is useful in our daily life. For example, if you are thinking about a day, we can't think a day without a plastic, because especially for what we have the normal household items, what we can have the bottles and the tiffin box, and we have some of the ornaments, and we have something like our tires, tubings, and we have some safety tools just like a gloves and some of the safety apparatus, etc. So why these materials are so important? We have to think about that one. So always we have to compromise with the price and the quality of the product what we are going to make actually. So polymers can be converted wide variety of the, or polymers can be used to make wide variety of the material. That can be a hard material or a rigid material, or it can be a semi-rigid material, it can be a flexible material, or even it can be a very soft material, just like our food items. So if you are going to think about the properties of these materials compared to any other material, just like a big stone or a hard stone or any of the metals what we can have, compared to those things, we have high strength for these materials. And another property is just like compared to other materials, the plastics are very lightweight. So we can think about replacing many parts of the engines or machines or many articles that can be easily replaced. The metal we can be easily replaced by the plastics, etc. So apart from this, we have another, or we have different kind of properties for this material. Because of this flexibility, we can easily mold into any desired shapes. As we know, there are some limitations for coloring the metals or the articles that is made up of the metals or stones. We have to paint after making the article. But in the case of the plastic articles or polymer articles or any material that is made up of the polymer, we can introduce, before going to shape the material into a desired shape, we can introduce different colors to these materials, or we can color the material before going to manufacture. Then we have these materials are, compared to the metals and compared to any other inorganic or metals, etc., we have a good resistance to chemicals, these materials. So we can use it for making the tanks, or we can making the some of the storage of the chemicals, etc. And again, as we can see, these are the very resistant to corrosion or air. So the damage from the long term use will be quite less compared to other materials. So as we know, if you are looking at a material that's we are going to use in our daily life, we always compromise with the low price and good quality. So compared to any other materials, we have the new materials that is called the polymers. We can make any desired shape, any type of the articles and any color with less expense actually, because we need to use only lower energy for the production of the many polymer items compared to those we manufacture from the metals, etc. So if you compare the superior or the improved property of these materials compared to others, for example, we have a material that is called a polycarbonate. We can make a sheet of this polycarbonate that will be useful for the protection. Actually, these are the bullet resistance panels we can make of this polycarbonate. It combines the property of the glass. It is a very transparent material, and again it is strong as steel as well. in this section I am going to tell you about some introduction to the polymers, how the polymers are made and how they are classified according to different categories actually. So, for example, as I told before, polymers are the big molecules or giant molecules that is built from a small molecule. For example, we have ethylene, that is a small molecule, that's we call the monomer. Actually, the meaning of the monomer, that's a Greek word mono, that means the single, and mer means that is a unit. So, it is a single unit of this molecule. So, this single unit we are going to add into other unit, then again to another unit, and a n number of the unit we are going to add. For example, we are taking the ethylene, then we are adding another ethylene monomer unit to that one. So, you are ultimately going to make a butene. So, again we are adding one more ethylene to that one, then we are going to make an hexene, then we are going to add one more ethylene to that one, that is called octene. So, as you can see, if you are increasing from the number of the carbon atom in a homologous series, or we can say in a alkene or alkane series, the property will be changing. So, for example, we have a ethylene, that is a monomer, it is in the gaseous state. So, we can say simply C1 to C3 or C4 are the gas molecules. Then if you are increasing the number of the carbon atom in the chain, for example, we have the hexene and we have the octene, etc., that are the simple liquid molecules. So, if you are adding only few units, that is the ethylene plus another ethylene and with another ethylene up to 2 to 3 or again 4 to 6 or etc., we are going to make a small molecule again, but it is not too large as a polymer and it is not too short or small as just like our monomer unit or our single unit, that is ethylene. So, in this case we call these are the oligomers. Actually, the meaning of oligo is few. So, few units are joined to make a oligomer, still it is not a very big molecule. So, in the case of the polymers, compared to the monomer, compared to the oligomer, we are adding many number of the monomer units, just like a n times we are just adding. So, it is just like a hooking beads on a chain, we are adding a single bead, then we are adding another bead and we are adding another bead. So, n times we are just hooking the beads on a chain, we are getting a large or long chain in the form of a polymer. So, basically we are saying a polymer consists of a large chain of repeating molecules that are the monomer units actually, that are attached in an end to end fashion by a chemically, or we can say that is a covalently bonded with each other. So, the monomer is a basic building block of a polymer, that is a single unit, or we can say that is a very short unit. So, as we can see, as I told before, if you are increasing the number of the carbon atom in a series, actually the property will be changing. So, we can see that at a glance we can say the property of the polymer will be entirely different from that of the monomer or that of the short unit what we started to make these type of the very large polymer molecules. So, here we have a very huge molecule, sometimes this is called macromolecule. As you know, macro means it is a very big molecule. So, it contains a bunch of the monomer units that may be starting from several hundred to thousands, or maybe from thousands to million or billion, etc. So, as I told, the chain length of these polymers sometimes defines the many characteristics or its useful properties. So, if you are going to talk about this chemical structure of the polymer, we have to remember, or we have to think about the two great scientists, that is, one is the Hermann Francis Mark. Actually, he has done some work on the crystal study of the X-ray study of the polymer molecules, and another scientist, that is Hermann Staudinger. He also developed some of the theory related to the macromolecules or hypothesis. So, now I am going to talk about the classification of the polymers, that is the type of the polymers. Based on the different category, we are classifying the polymers. For example, we have based on the origin or the source from where the polymer we can get, we are classified that into a natural polymers, and we can have the semi-synthetic polymers, and we can have the synthetic polymers. For example, as I explained in the first section, we have the many natural polymers, as we can see. For example, we have the cellulose in the wood and cotton, and we have the starch that what we can see in potatoes and corns and many food items, and we have the wool that we can get from the sheep actually. Then we have the silk that we can get from the silkworms. Then we have of course the natural rubber that we can obtain by tapping of the rubber tree. Then we have the pitch that is obtained from the oil deposits. So, these materials are very useful in our daily life, that we are going to make a different article from these materials. Then we have the semi-synthetic polymers actually. So these are the kind of the natural polymers we are modified by treating with some of the chemicals, or we are improve the property of the natural molecules by attaching some specific functional groups or some chemical reagent to that one. For example, we have the cellulose, that is a naturally occurring polymer. We are going to modify that into a cellulose acetate, they are getting a different properties, and we have another material that's I already discussed, cellulose nitride, that is we can use it as a gun cotton. Then we have another material, that is carboxymethyl cellulose, that we are using as a thickener for many food products. Then we can have the regenerated cellulose fiber, that is called the rayon, that we use mainly for the textile industry or making of the clothes what we can have. Then another type of the material that is very common, that is the synthetic polymers, that we can call the man-made material, that is the commodity plastics and engineering plastics and any kind of the plastics or polymers that is available in the market. For example, we have the polypropylene, we have the polyethylene, and we have the polyvinyl chloride, that is called PVC, and we have the polystyrene and different kind of the material that's made by the human beings. So another type of the classification what we have is the based on the chemical nature actually. So we divided these category into two, that is the organic polymers and other is the inorganic polymers. Organic polymers is the basics what we explained already, whose backbone chain is essentially made of carbon atom. For example, we have the polyethylene, that is made up of the monomer unit, that is the ethylene units as we know, CH2. So this will be the repeating unit of this one. So if you are looking at the polymer chain, entire backbone is made up of the carbon covalent bonds. So another type of the polymer, as we can guess from the name itself, that is the inorganic polymers. So as you can see, the backbone will not be made up of the carbon, it will be the atom other than carbon. So for example, we have the glass, it is made up of the silicon, oxygen, silicon linkages, and we have another material, that is the silicon rubber, we can have the siloxane linkages actually, that's the another type of the inorganic polymers that we have a very useful properties. We have another type of classification of the polymers, that is based on the monomers involved. For example, we are going to make a polyethylene, that is the monomer unit here is the ethylene, we are going to polymerize, that is n times you are taking the ethylene, we are going to hook it up together. So we have the polymer chain that is entirely made up of a single monomer unit. So these type of the polymers we call the homopolymer. For another example, we can say the polypropylene, we are taking the propylene monomer, then we are going to polymerize the propylene, we are getting a polypropylene. So these are the kind of the homopolymers that uses only a single monomer unit. So other kind is just like we call heteropolymer or copolymer. Instead of using a single monomer unit, we can have or we can mix the different kind of the monomers, they will be going to polymerize. For example, instead of taking the homopolymers of the ethylene and propylene, we can take the two monomers, that is ethylene and propylene. You are going to polymerize these things together in a single reactor. So what we are ultimately getting is a copolymer that contains the repeating unit of ethylene and another repeating unit of the propylene. So we have ultimately ethylene propylene copolymer in our case. So for example, another example we can have the styrene, maybe we can take, we can mix it with butadiene. So we are going to make a copolymer, that is styrene butadiene copolymer. So as you can see from the chemistry, the property of these homopolymers and the property of these copolymers will be entirely different. So we can find out the suitable applications where we can use this type of the homopolymer, or where we have to use this type of the copolymers, etc. We have another type of the classification of these type of the copolymers actually based on the arrangement of this monomer unit along the chain. For example, if you are going to make a copolymer of A and B, that is the monomer unit A is going to react with the monomer unit B. So we are getting a long chain that containing the different monomers, that is A and B. If you are going to arrange this monomer unit in different fashions, for example, we can have an alternate arrangement of A and B. So it is just like if we are putting a bead of A on a chain, then thereafter we are putting another bead that is made up of B, and we are again putting another A and again B. So it is an alternating fashion of the monomers, that is called alternating copolymers. Otherwise, we can do a random arrangement. Suppose we have a single monomer unit, that is the A, and thereafter we have a 2B, and thereafter maybe we have a 3 A's, and again thereafter maybe a single B, etc. There is no proper arrangement of these two monomer unit on a long long chain, that is called a random copolymer. Otherwise, what we can make, we can have a block of each monomer type. For example, we have a polymerization of the A and we are getting a block of a 5 units of A, it is making a block. Then thereafter we are making 5 units of B, that is making another block. Then again we have another block of A, and again we have another block of B, etc. These type of the arrangements or these type of the chains that is made by these reactions, that is called a block copolymer. And another last category, we can say we can have a chain backbone that is made up of a single monomer unit. For example, we have the backbone is entirely made up of a monomer unit, that is A, and we have some branches or we have some grafted point, etc. We have something like made up of a monomer unit B. So it is just like a grafted copolymer we call. Next classification we have based on the polymerization reaction what we use to make the polymers. These are two kinds actually, one is called addition polymers and other is called condensation polymers. In first category, that is addition polymers, here we are simply adding the monomer unit to each other, there we are making a big molecule. So here what we can see is there is no loss of any atoms from the original monomer molecule, so entirely we are going to get the total molecule on the polymer chain. So if you are thinking about the molecular weight, or simply we can say molar mass of the molecule, it will be just the simple addition of the individual monomer units. For example, we have the polyethylene or polypropylene and the polystyrene. These are the addition polymers simply added to each other, making a big molecule or a giant molecule. In the other type, that is the condensation polymers, we are just doing a reaction that will be simple molecule will be coming out of this reaction. For example, if you have the reaction between the terephthalic acid and the ethylene glycol, they will be going to make a condensation polymer. The reaction will be releasing some of the small molecule just like a water and methanol. So as you can see, as I told, compared to the addition polymers, always there will be some loss of the atoms or molecule by doing the reaction between these monomer units. So the molecular weight or molar mass of the condensation polymers will be relatively less compared to the total weight or total molecular weight of the monomer units what we are used for the polymerization reactions. Then we have another type of the classification that is based on the topology, or we can say that is based on the architecture. We have a linear fashion of the molecules, that is simply of a long chain molecule, and we have another type is the branched polymers, that is we have something like a long chain, linear chain, and we have some of the branching in between these chains, etc. Then we have another type of the architecture or the topology that is called the cross-linked. So in the case of the cross-linked polymers, we have some of the linkage between the holding of the chains together by a cross linking. So as you can see, if you have a fashion like this one, the property of these materials depend upon the type of the architecture or the topology will be entirely different from the linear to branched to cross linked polymer. So I already discussed about the different type of the architecture, or we can have the some of the branching and cross linking in the polymer molecule chains. So based on the different type of the branching, we can further classify the branched polymers into two actually. So we have one type that is a short chain branches. Suppose you have a long polymer chain, we can have a short chain in between these molecules maybe. Then we have another type of the branching, instead of the main backbone, we have the long branches that will be starting from the main backbone. So as I told, the structure of the polymers define its main characteristic and many properties. So the property of the short chain branch will be entirely different from a linear chain, that will be entirely different from a highly branched or long chain branching, etc. Then we have another type of the classification that is based on the mechanical properties and the behavior. We classified mainly that into four. The first one is the plastic, and the second one is the elastomer. Then we have the fibers, and we have something like a liquid resins. So we have the first category, that is plastics, material capable of being shaped or molded, can be deformed by the force and do not restore easily. So rigid material that we can make into a plastic material, that is which have a definite dimension, we can use it for the many purpose. Then the second category, that is the elastomer, or we can say rubber. As the name indicates, this is just like the material that have some elastic property, or we can say we can be stretch the material into 4 to 10 times its original length, and when the force is recovered or when the force is removed, it will go back to its original length. Then we have another material, that is the fibers. It is just like we are drawing the polymer into a long filament like material whose length is 100 times greater than its diameter. So these are very strong. There is a strong intermolecular or intramolecular forces between these molecules. So compared to the rigid plastic, fibers are more strong and it is high tensile strength compared to the plastic materials, what we can say. For example, we have a nylon fiber we are using for tying many of the hard material which is very strong, and we have the rayon, that is the artificial silks that we made from the regenerated cellulose fiber, that is very quite strong because of this fiber nature or the fiber structure. Then we have the liquid resin, that is mainly the polymers in the form of the semi-solid, or we can say in the liquid form actually. For example, we have the adhesives and potting compounds and the sealants, just like a silicon resins, epoxy adhesives and polysulfide sealants, etc. what we use in the form of a resin, that is called the liquid polymer resins. Then we have further classified the synthetic polymers based on their thermal response. This is quite important if you are discussing about a plastic. That is, one category is the thermoplastics, another category is the thermosets. So thermoplastics, the first category, these can be softened by heating and hardened by cooling. So it can be easily recycled, or we can convert from one shape to other shape by applying a heat energy. So these are easily converted into various shapes and thermally recoverable material. For example, we have a polyethylene. If you are making a plastic mug from a polyethylene, after applying sufficient amount of the heat, or if you are coming to a molten state of the polyethylene, we can make a plastic spoon from that one, or we can make a plastic bottle from that one. So these thermoplastics are thermally recoverable, so we can make into any desired shape after applying the heat. But in the case of the other category, that is the thermosets, this will be getting hard, and if you are heating the material, there will be cross-linking of the polymer chains that will be going to happen. The material become very hard and rigid. So thermal recovery is not possible with this material. Once you make a particle, that you can't be change into another shape by application of the heat. So for example, we have the phenol formaldehyde, that is the bakelite what we made. It is very tough plastics. We can reshape into another shape by application of the heat, that is called the thermosets. So based on the performance, we can further categorize these type of the polymers into commodity plastics, then intermediate plastics, engineering plastics, advanced or high performance plastics. As we can see, the commodity plastics was what we use in the daily life, which must have something like a low mechanical strength or low tensile strength and low weather resistance, etc. For example, we have the polyethylene, polypropylene and polystyrene and PVC. Then we have something like a other category, that is the intermediate plastic with a bit improved properties or higher mechanical strength. Then we have the third category, that is engineering plastics with a much better improved property that is used for making such articles. For example, as I told, we have the polycarbonate, then we have the nylons, and we have the polyphenylene sulfides, etc. So the last category, that is we have the advanced or high performance plastics. For example, we have with some special properties and the special applications what we are going to use, that is the liquid crystalline polymers, and we have the polyether ketones, and we have the polyether sulfones, etc. that is called high performance because of its property and use. So I was talking about different properties and application of the many polymers, whether it is a natural polymer and synthetic polymers, and we are making the superior properties of these materials. But apart from these characteristics, we have some limitations for these polymers. One of the great problem with this is that unfortunately these polymers do not easily degradable, or we can say it is not biodegradable, and it make a lot of problems, just like a large amount of the waste it will be introducing to our environment. One of the solution for this problem is that we have to recycle major portion of these plastics. Otherwise, we have to find out some of the eco-friendly or environmental friendly polymers, that is called biodegradable polymers. Some of the polymers are available in the market, but compared to, as I told, if you are comparing or if you are compromising with the price and the quality of the product, it is quite expensive compared to the normal commodity plastics what we are going to use. So we have to find out an alternative for these materials. Still scientists are working on that one. So hopefully we will be getting some of the biodegradable materials in the future, just like what the scientists they bought into our daily life, that is this great thing, that is the polymer what we discussed up to now. Thank you for listening. In the next lectures, we will be going to discuss about the individual polymers and their properties and applications, etc. Thank you.